Howdy, today we've got section 7.6. We're solving exponential and logarithmic equations. Too bad I can't say that very well. Try it again. Today we're doing section 7.6, solving exponential and logarithmic equations. We will be splitting this into two parts. First part today we'll be solving exponentials, and then tomorrow, or Monday actually for you guys, we'll be solving logarithmic equations. At this point, I honestly think 7.6, which is kind of closing out the chapter, is easier than section 7.5. 7.5 tends to give students a lot of issues. Go back and work on 7.5 if you don't know how to do it. 7.6 is pretty straightforward. Like I said, we're going to be solving. We'll use our calculator a little bit. I'll tell you when and where to use a calculator. A reminder on your exam, you will not be allowed to use calculators, so I'll show you how far to take a problem as far as working it out and what the expectation is and what I'm looking for out of you guys. So again, make sure you're comfortable with 7.5. That's the tricky area. The rest of the logarithmic unit tends to be pretty smooth. This is closing it out. We've graphed exponentials, we've graphed logs. We've played around with E, we've compounded interest. We have found inverses. We've looked at the relationship between X and Y. We've looked at vertical asymptotes. We've looked at horizontal asymptotes. We've looked at domain restrictions. We've looked at range restrictions. And now we're going to end up with solving them. Like I said, solving, pretty much use the inverse to solve the equation. Use the inverse to solve the equation. That's what we're going to do. I'll say it again. We're going to use the inverse to solve the equation. Name of the game is going to be matching up bases, which is what we've done before. Matching up bases using inverses. Here's what it's going to look like. We've got 3 raised to the 7x minus 3 equal to 9 raised to the 2x. Now you guys would tell me I'd probably do something, same thing to both sides of the equation in order to get rid of the bases. Obviously we're trying to solve this equation for x, which means we need to get rid of bases. The only problem is, on this example, I have a base 3 on the left-hand side and a base 9 on the right-hand side. So I can't really do anything to get rid of the bases yet. But I can rewrite, I'm not going to rewrite my 3, by the way, 7x minus 3. I can rewrite the 9. Because instead of not writing 9, I'm going to write 9 as 3 squared. So again, matching up the bases. 3 squared raised to the 2x. You should know how to simplify the right-hand side. On the left-hand side, I have 3 raised to the 7x minus 3. On the right-hand side, I have 3 to the 4x. Again, when we're raising, that means multiply. At this time, it should make sense that our bases match up. Since our bases match up, and I'd like to get rid of a base, because I want to solve the equation for x, I will introduce, let's see, I want to get rid of a base, so I will introduce a, you should say log right now. I'll introduce a log base 3, a log base 3 to both sides of that equation. So to get rid of the exponent, introduce a log. And then I'll say matching basis. It's almost as if we've been leading up to this the whole time. Because, oh me, oh my, I am shocked to see I have an identity here on the left-hand side. And the left-hand side will simplify to 7x minus 3. And on the right-hand side of this equation, oh me, oh my, I'm shocked to see that there's an identity on the right-hand side of the equation, and that simplifies to 4x. And I've just gone from solving a relatively complex exponential equation to a one-variable linear equation. So at this point, solve for x. minus 4x from both sides. That says 3x minus 3 equals 0. Add 3 to both sides. And 3x equals 3. Divides out both sides by 3, and x equals 1. You're done. You can always double check your work in these problems if you'd like. Plug it back into the original equation. If you plug 1 into the original equation, that says 7 times 1, which is 7, minus 3, which is 4. So the left-hand side says 3 to the 4th. The right-hand side says 9 to the 2 times 1. That's 9 squared. 3 to the 4th is the same thing as 9 squared. 81 equals 81. So that number fits. That is also correct. All right, next problem. 4 raised to the x equals 1/2 raised to the x minus 3. Well, 4 is not the same thing as 1/2. I need to match the bases up. However, will I do that? I think the easiest way to do it is get both of these as some expression of the number 2. So I'll rewrite 4 as 2 squared. And then I'm going to rewrite 1/2, and some of you guys already figured out where I'm going. I'm going to rewrite 1/2 as 2 to the negative 1, and that's to the x minus 3. So now I have 2 to the 2x equals 2, and remember I raised to an x, so I have to multiply, just like I multiplied there. That will be negative x plus 3, distributing the negative 1 times x minus 3 gives me negative x plus 3. A lot of students will make a mistake right there with this plus and minus 3. A negative times a negative is a positive 3. I've matched my bases up. I want to get rid of a base 2 from both sides of the equation. To get rid of a base 2, I will, this is where you say log, introduce a log base 2 to both sides of the equation. Oh me, oh my, I am shocked to see that I have an identity and I have 2x on the left-hand side. On the right-hand side, I have an identity and negative x plus 3. I have a one-variable equation that I can solve for. Add x to both sides. That gives me 3x equals 3. Once again, I'll divide by 3. And yes, I will tell you, it is a coincidence that both of these numbers have x equal to 1. Your answers will not always be x equals 1. Match the bases, introduce a log, solve for x. Checkpoint. Pause the video, match your bases, introduce the log, solve for x. Pause, unpause when you're ready to roll. Okay, you should have done that checkpoint just now. Heading on to the next set of problems. Just a little bit more than what we've been doing already. 5 to the x equals 72. 5 to the x equals 72. Mr. Wood, you just said the name of the game is to match the bases up and take the log of both sides of this equation. As best I can tell, I cannot rewrite 72 into a base of 5. So this technique is not going to work for us. In other words, it doesn't simplify down. 72 is not, I can't rewrite it. Mr. Wood, since I can't rewrite it, that doesn't make any sense. There must be a mistake in this problem. I'll just skip it and go to the next problem. No, you're not just going to skip it and go to the next problem. There's a way to do this problem. In fact, what I'm trying to do is solve for x. And since I'm trying to solve for x, I will get rid of my base 5. However in the world will I get rid of a base 5 from the left-hand side of my equation? This is where you say log 5 both sides of the equation. That's right. You log 5 both sides of the equation. So if I log 5 on the left-hand side, I need to take a log base 5 of the right-hand side. So on the left-hand side, I have an identity. I have x equals the log base 5 of 72. And if this was on your exam when you weren't using a calculator, that's good enough for me. You can leave your answer as log base 5 of 72. If it's on the part of the quiz or if it's on the part of the test where I allow you to use your calculator, then you will need to take it a step farther and use the change of base formula. Change of base, you did it last night on your homework. That's log of 72 divided by the log of 5. Log of 72 divided by the log of 5. Put it into your calc. I don't know what that is. .657. So, your answer without a calc, and this is your answer with a calc. I expect you to be able to do both. Now, it wasn't that hard, Mr. Wood. What are you setting me up for? Another checkpoint. Pause the video, solve the problem, and go ahead and give me the calculator solution on it. So, solve the problem and give me the calculator solution on this. Pause the video. When you're ready to move on to the next problem, we'll go. Unpause it. All right. Welcome back. Hopefully you got that problem done. We'll look at it in a second. Next example we're going to look at. Oh, that looks hard, Mr. Wood. 6e to the 0.25x plus 8 equals 20. Yeah, no, that's not going to work. Dude, it's easy. Just like the other problems we've done with radicals. Isolate the radical, introduce an exponent to the both sides, and solve. In this problem, we don't have radicals, we've got exponents. So we should isolate the exponent and then log both sides instead of introducing an exponent, and then solve. It's almost the exact same thing we did in the last chapter, except for instead of having radicals and fractional exponents, we have bases, exponents, and logs. Lions and tigers and bears, oh my. Same thing over and over again, oh my. So 6e to the 0.25x plus 8 equals 20. We need to isolate the exponent. The way that we're going to isolate the exponent, minus 8 from both sides of that equation. That gives me 6e to the 0.25x equal to 12. Need to get e by itself? I will divide both sides by 6. That gives me e to the 0.25x equal to 2. I've isolated the exponent. Log both sides. I need to get rid of a base e. However in the world will I get rid of a base e? This is where you say log e. And I'd say, right, we need to take the log base e of both sides. But we don't call it the log base e, we call it the natural log. So I will take the natural log of both sides of this equation. There's my identity. The natural log of e is 1. So that gives me 0.25x equals the natural log of 2. I've now logged both sides. Solve. 0.25x equals the natural log of 2. Divide both sides by 0.25. That gives me x equals the natural log of 2 over 0.25. Without a calculator, that's the answer I want. With a calculator, I want you to finish the problem. X is approximately, you need to take the natural log of 2 in your calculator and divide it by 0.25. I'll show you that calculation real quick. We need to take the natural log of 2 and divide it by 0.25. And take the natural log of 2 and divide it by 0.25. 2.773 is what we'll call that. 2.773. And that's your answer with a calc. Again, depends on if I give you a calc or not. No calc, that's what I want. With a calc, that's what I want. Isolate, log, solve. You guys. Pause the video and solve the problem. When you're ready to move forward, go ahead and unpause it. All right, if you're done with the problem, here we go to the next problem. We're just about done. Actually, we are done. Today's password is Happy Halloween. Today's password is Happy Halloween. Come to class ready to work on these kind of problems, and we will do a couple of extension application word problems on this. So make sure you're okay with the nuts and bolts on how to solve, because we will extend this tomorrow in class. Again, today's password is Happy Halloween.